Greetings to you all. I'm Ms. Sibia MP. Will be presenting another topic saying enhance heavy metal piezocatalytic adsorption and antibacterial activity using kaolin modified PVDF monofibers method of water treatment. I will be presenting along with Ms. Ngubane F, Mr. Rachebu BN, Ms. Shabangu SN, last but not least, Sibia AM. Okay. In introduction, water pollution are critical challenges due to heavy metals and pathogenic microorganisms. It was found out the high level of chromium, lead, zinc, and mercury found in South African waters are high. The World Health Organization permissible limits are often exceeded, posing health and ecological risk. Conventional treatment method are chlorination, UV, reverse meiosis, ion exchange, having a limitation like higher cost, inefficient, and bacterial growth.
Greetings to you all. This is Miss AMCBI and I'm going to be taking you through the aim and objectives. The main aim is to develop and evaluate kaolin modified PVDF nanofiber methods for enhanced piezocatalytic absorption of heavy metals and antibacterial activity in water treatment applications. Then we move to the objectives. The main objectives are to synthesize and characterize kaolin modified PVDF nanofiber methods with varying percentages of kaolin via electrospinning, and also to evaluate the piezocatalytic absorption efficiency of nanofiber methods for the removal of heavy metals such as silver, chromate, lead, and zinc from both simulated and real waste water under ultrasonic vibration, and also to optimize operational parameters such as kaolin content percentage, pH, contact time, and initial metal concentration, and also to study and assess the reusability and stability of absorption kinetics in antibacterial activity.
Greetings everyone, I'm Ngubane and I'll be taking you through the methodology part. In this research, the methodology outlines the strategy we use to address our problem and guide the investigation, including both the steps taken and the rationale behind them. We used a primarily quantitative approach to evaluate the efficiency of kaolin-modified PVDF nanofiber methods in removing heavy metals and inhibiting bacterial growth. This approach allowed us to generate numerical evidence on material characteristics, performance comparison, and cause and effect relationships. The research question was: can kaolin-modified PVDF nanofiber methods enhance water purification through piezocatalytic adsorption of heavy metals and antibacterial activity? To answer this, we examined the material properties and relationship between kaolin loading and performance. The data we used were secondary sourced from a published article. The original research tested PVDF nanofiber methods blended with varying amounts of kaolin against 4 heavy metals, that is, silver, chromate, lead, and zinc, and 3 bacterial strains. The original experiments used several instruments, including X-ray diffraction, Fourier transform infrared spectroscopy, scanning electron microscopy with energy dispersive X-ray, and electrochemical techniques with ICP OES for measuring residual heavy metal concentrations. The procedure involved preparing kaolin PVDF nanofiber methods via electrospinning and testing their adsorption efficiency under different pH levels, contact times, and metal concentrations. Antibacterial activity was evaluated using disk diffusion and variable cell count methods. Adsorption efficiency was measured as the percentage of heavy metal removed, while antibacterial performance was assessed through inhibition, zone sizes, and bacterial survival counts.
I'm Miss AMCB and I'm going to be taking you through data analysis, which is quantitative analysis. We compared heavy metal removal across conditions, applied kinetic models to understand absorption trends over time. The outcome of the methodology enabled measurement and comparison of nanofiber mat performance, produced objective, reliable results, provide insights for real-world water purification applications.
As my colleague stated, I'm Richiko Vasinimron. I'm going to do the results and discussion of piezocatalytic absorption of heavy metals. As our PowerPoint stated, as the PowerPoint showed a bar chart. It's titled the piezocatalytic absorption of heavy metals on electropalm, non-fiber mere visual. The representative remarks effectively and newly developed material as shown in the bar chart. The nanofiber made successfully removed from a high percentage of each tested heavy metal, then this demonstrating its strong capability and absorption of cleaning capability. The chromium, as you know, is shown in the periodic table, or the atoms, there are four, which is lead on the periodic table, and lead, chromium, silver, and zinc. Each they were tested, which were removed according to the pie chart. It shows the made achieved percentage. The made achieved a percentage of removal of efficiency of chromium indicate that the complete successful eliminating this highly toxic pollutant was 100%, which removed all the toxins. The lead, the result for lead were also exceptional with made achievement of 93%, but 70% was left, but 93% was moved efficiently at criteria, finding a give and rent as a nature. Silver, as we know, is plus in the periodic table. They may demonstrate the strong performance by removing 78% of silver from the water, which is stated in our graph. And finally, we have zinc. We know zinc is that in the periodic table. The efficiency portion of zinc was also removed with a efficiency of 72%, which was less, it was the lowest. This result confirmed that the nanofiber mat is powerfully and tool for water pollution purification capability of efficiently and targeting the multiple heavy metals contamination.
Greetings to you all. I'm Ms. S. N. Shabam. I'm doing the conclusion part. This study has made special mats from PVDA mixed with kaolin to clean water. These mats could remove heavy metals like silver, chromium, lead, and zinc very well with the 0.5% Ka PVDA mat working the best. The process mainly relies on strong chemical bonding, and the mat stayed effective for up to 3 uses. These mats also killed harmful bacteria such as Staphylococcus aureus and Pseudomonas aeruginosa, although they were less effective against E. coli. Adding kaolin improved the mat surface strength and ability to fight bacteria. Acknowledgements. Under the fundings, we have a national research funding, Center of Nanomaterial Science Research at the University of Johannesburg. Under the supporters, we have University Academic Development Program, Department of Higher Education in South Africa, technical assistants, we have Dr. B.C. Dlamini, Nontobeko Zulu, Department of Biotechnology at UG. And we have Prof. Nonhlangabezo Magula, and the Department of Chemical Science, University of Johannesburg, Doornfontein Campus, Republic of South Africa. And the Center of Nanomaterial Science Research, University of Johannesburg, Doornfontein, and Department of Chemistry, School of Physical and Mineral Sciences, University of Limpopo.